Alright, so I forgot to talk about a couple things in the last video, so this is continued. Replacement and without replacement, we've been doing this for a while now. Essentially, with replacement means like whenever an event occurs, you essentially put the set back. You actually put the sample set back to the way it was before. So the probability of a spade of you just drawing a spade out of a deck is 13 out of 52. If you take the spade out and then you put it back in, your probability of drawing another spade is going to be 13 out of 52 again. However, if you don't put the card back in, it's going to be 12 out of 51. This is kind of logical, and it just shows the difference between with and without replacement. We've all been doing this with NCR and all that other good stuff that we've been doing for the past couple of years, so we should all be pretty good at this. This is now conditional probability. This is essentially a small proof how to get to the answer. For example, the probability of two events both occurring. An example would be like, I don't know, let's say a math teacher gives out two tests and 25% of the class passes both tests and 45% of the class passes the first test. And your question is, what percent of those who pass the first has also passed the second test? Here exactly is actually a proof for it. It's essentially basic algebra. Probability of A and B is equal to the probability of A times the probability of B, A. A little bit of algebra kind of goes through, and you actually get right about here is your equation that you can use. And then from that point on, conditional probability is essentially when one outcome actually affects the other outcome, or when an outcome is actually the intersection of two sets. And basically, to prove independence, easiest way would probably have to be if you can find an intersection of two sets. If there's a way that you can intersect two sets, or if you can actually prove that one event is not caused by the other one, or if you can prove that there's actually no effect that one has on the other, that's the easiest way to prove independence. It's kind of intuitive. All you have to do is kind of think about it, and that should be about it.